Like I said, my name is Liz Amos, and my colleague, In-Hye also helps me, and she's part of our terminology services at the National Library of Medicine. And I presented earlier this morning with Christoph, and I work with him on the NIH CDE repository. And today I'm going to be talking about addressing connections between common data elements and standardized clinical terminologies. And so I'm hoping to give just a very brief overview of some of the vocabularies required for meaningful use. And we'll also go over a little bit about the UMLS, which is the Unified Medical Language System, which is our metathesaurus, which actually will connect you to a lot more terminologies besides the three I'm going to go over, but an important resource and how you can access that, as well as talk about how these connections will enable or in some ways help provide a bridge to connecting clinical data sets from encounters and clinical research. And so this is kind of my interpretation of what would be ideal for how research studies could be described. And I'm kind of basing this off of how dbGaP is constructed in a lot of ways, where you essentially have these different layers of how a study is documented. So at a study level, a data set level, and kind of the documentation surrounding that. So what types of protocols, and in the very middle, the variables. And so that's kind of the space that the CDE repository lives in, is this innermost circle, if you will. And so the variables and the different case report forms or instruments that help describe these different data sets. And so kind of in this example, I wanted to show what we're attempting to go for is being able to show relationships between variables and forms and how that can be used to connect different data sets. And so, for example, let's see, this is my pointer. So in study A, data set 3, and study B, data set 3, they're both using a form named vital signs. Although you can see in the study A, it's using systolic blood pressure, diastolic blood pressure, and position, where in data set 3, it's only capturing 2 of these variables. So whether or not that's actually the same or different, that's kind of the question that we have. Also, and then another example, so in data set 2, in A and B, here I've got 2 of the same variables, so age at first cigarette and drinks per day. Study A is calling it substance abuse, and study B is calling it alcohol use. So it makes it very difficult to be able to find those or how they might be related. And then finally, I go flying forward. So what I think really starts to get to be interesting is when we drill down even further to express the data types of the variables in between here. And so for something like diagnosis, study A might be expressing this as a free text, and study B might actually have a value list or pick list. So that can make it very difficult to be able to compare those two and the answers that come out of them. And also you could actually both have pick lists, and one's expressing that in terms of ICD-9 codes, and the other one is expressing it in terms of Snowden codes. So how do we get to be able to discover those? And in a lot of ways, terminology can help us bridge those connections using the concepts behind them. And so like I said, I'm going to briefly cover going to SNOMED and RX norms, if you're not familiar with them. The UMLS is the metathesaurus, like I mentioned. And that it contains a lot more of vocabularies besides just the ones for meaningful use, over 200 source vocabularies. So I'm put down here just there's administrative vocabularies and ontologies as well as genetics. So it covers a very broad domain of biomedical terms. And so the Common Data Element Repository is one terminology tool at NLN. My counterpart is also the Value Set Authority Center, and that was originally designed for developing value sets for CMS clinical quality measures, although they've actually been it's available for use for other purposes as well. And so we found that I think there was a group, Vanderbilt Emerge project actually has sets of values to phenotype their electronic health records. We've talked about Minimap, and also the EMLS is available through an API. So clinical terminologies are used to represent key health information exchange occurring in a clinical setting. So whether that's at a doctor's office, a hospital, or a pharmacy. And it contains both a human-readable description or names and a computable readable code. So computable readable code. And that code allows computers to exchange health information. And so this example down here is kind of showing this process. And so RxNorm is a very large normalized drug ontology. And so what that means is that it's all being expressed through one code. And so that way, in this diagram, a patient comes in for an encounter with a complaint, and that information is going to be documented inside of an electronic health record where the physician or provider might order tests using a LOINC code describing the problem or disease and a problem list with the SNOMED code, and prescribing a drug using whatever proprietary system, which actually, this all happens in the back end. That will get sent to the pharmacy, and so they might be using an entirely different ontology. They can take that information and also bill the health insurance company, which might, again, be using a different code, but using RxNorm helps transfer all of this information so that you know exactly what code, what strength is being asked for here and paid for there. Quickly, SNOMED stands for Systemized Nomenclature of Medicine, and it's the most comprehensive and precise multilingual health terminology in the world. It covers a broad list of terminologies for clinical purposes, including problem lists and a lot of public health reporting. And so I just listed down here an example of what that would look like. NLM provides this for free for the U.S., and so this is available to you through the UTS, the terminology services. LOINC is kind of the laboratory side of that, and this provides a set of identifiers, names and codes for identifying health measurements, observations, and documents. So in a lot of ways, you can think about this as a question and an answer. And so this LOINC code contains all of that information, so the name and the answer, whether that be a list of answers or like a measurement of some kind. And then finally, I have already talked a little bit about RxNorm, but it is a naming system for generic and branded drugs in the United States. And so this is how we might be able to bridge elements inside of a case report form to how it could be expressed in an EHR setting. So in this example, this is a potential study for, I actually took this from a clinical trials record, and they had documented it so well I could kind of extrapolate some of it. But basically we wanted to create some eligibility criteria. So in terms of how we might express this in terms of a question, what is your birth date and expecting the date, this could also be encoded with a LOINC code, which is meaningful in the EHR. So this is an example of just how we might be able to be really precise in what it is that, what questions are being asked in the case report form here. What the advantage is of using a case report form and why it's important in clinical research, that the terminology itself doesn't have the context of how this is actually being asked. So the CRF, this case report form, in many ways is acting as a container for describing eligibility criteria, which in this sense is kind of meaningless because it's just a very large collection of data. But okay, so just to go over the UMLS. So actually in the previous slide, so I'm referencing specific codes here. line codes, these are SNOMED codes. These happen to be RX norm codes. However, we might want to be able to look for concepts. So, maybe I don't necessarily want SNOMED here. My system might be using something else. How can I bridge the concept of pregnant or not pregnant in a different vocabulary? And so the UMLS acts as a system of concepts, classifications, and resources to help bridge connections between different ontologies, all using a concept. So you can think of this as one metathesaurus to rule them all. But had to throw that in there. So the metathesaurus you can really think of as a giant thesaurus that contains over 3 million biomedical concepts and their synonymous names, their relationships, and their attributes. And so that's very helpful for whenever you are describing something, take for instance gender, and you might be looking for, or you might just have the answer of female. You might want to go up a level. And so what does female belong to? That belongs to the parent of gender. And so, like I said, the UMLS has over 200 different vocabularies, and this is just kind of a sampling of what that, and you might be familiar with ones like mesh. And so how the UMLS is constructed is basically in 4 different levels. So up at the top is the concept, and then you might have different lexical variations between that, different ways of constructing each string, so different clever and lowercase, punctuation, that kind of stuff. And this is all built off of the source vocabulary. So whether you're using an ICD-9 code, an ICD-10 code, those will appear at the bottom. And how that actually looks like, for example, this anatomy of a concept here for headache. Down at the bottom, here are the different terms, one for each. Headache actually kind of groups these 2 together, and then you can go up in the levels. So you can use these relationships to be able to extrapolate other information outside of this. So so it is challenging. This is all great. There is a lot of work to be done in this. So inside the CDE repository, we do have the infrastructure and the capability. Not a lot of these are annotated with controlled terminologies or concepts at the moment, but that's what we would like to encourage people submitting data to us to express it like that, because it does make it a lot easier to find things in the end. And also, my favorite here is encouraging machine-readable clinical research documentation, because a lot of these things are still expressed as PDFs, which can get very difficult to pull that information out. And then I've included some links in here for your pleasure at the end. So, all right, thank you.